We are going to go through 3 different types of simplifying radicals. The important thing is if your problem starts as a radical, your answer cannot have any rational exponents. So if there's still a fraction exponent or a radical in your answer needs to have radicals. If it starts with radicals, it needs to end with radicals, unless they are canceled out. Our first strategy. In number 8, we have the square root of 16 times the 4th root of 16. If they have the same index, say we have the 4th root of 2 times the 4th root of 8, if they have the same index, you can combine them and end up with the 4th root of 16. If they don't have the same index, you can't combine them. So our first strategy, if they don't have the same index, see if they can be simplified the way they are written. Strategy number 2, if they can't be simplified the way they are written and they don't have the same index, you can transfer into rational exponent form, simplify the way we did yesterday with rational exponents, and then convert your answer back into radical form. So number 8, they do not have the same index, so we can't combine them. Strategy number 1, see if they can be simplified the way they are written. Look at your perfects chart. What is the square root of 16? 4. What is the 4th root of 16? 2. So this is a really complex way of saying 4 times 2, which is 8. Now, because it was an even index, what is our answer? Plus or minus 8. Okay, in this one, the radicals completely canceled, so we don't have to worry about putting it back in radical form because the radicals are gone. Number 9, the 3rd root of 25 times the 3rd root of 5. Look in your thirds column. Do you see 25 in your thirds column? No. Do you see 5 in your thirds column? No. So we can combine these into the 3rd root of 25 times 5. What is 25 times 5? So let's look in our thirds column to see if 125 happens to be there. It does. The 3rd root of 125 is 5. And because this was an odd index, it's just positive 5. Okay, number 10. Actually, I'm going to let you try number 10 and 11 on your own. See if you can figure out 10 and 11. Go. Number 10, the 6th root of 8 is not on our perfects chart, but it's the same index, so we can combine it. 8 times 8 is 64. So now look at your 6th column. Do we know what the 6th root of 64 is? It is positive or negative 2. Number 11, same index, so we can combine these under the same radical. The 3rd root of 6 over 48. Now, what good does that do us? That's a fraction, 6/48, that we can probably simplify. And if you don't want to simplify it by hand, punch it into your calculator. If you have a newer graphing calculator, you can do alpha y equals, and it gives you a fraction feature. Alpha y equals pops up these fraction things. And then you can do 6 over 48 and let your calculator simplify it for you. It is the fraction 1/8. Or on a scientific calculator, 6 ABC 48, hit enter, and it will simplify the fraction for you. Now the question is our answer done? What I want you to think about is, do the numbers 1 or 8 exist in the thirds column? Yes. They do. So this is the 3rd root of 1 over the 3rd root of 8. What is the 3rd root of 1? 1. And the 3rd root of 8 is 2. 1/2 is a whole lot simpler than the 3rd root of 6 over the 3rd root of 48. Okay, number 12, honestly, it kind of boggles my mind, but whatever, we'll deal with it. Do you notice that the index is not the same? And square root of 5 is not on your chart. 4th root of 5, not on our chart. So, go back up to the top of your page. Strategy 2. If they can't be simplified and they don't have the same index, go to the rational exponent form and try to simplify that way. The square root of 5 is 5 to the 1/2. Remember, the denominator of the fraction is the same as the index. The fourth root of 5 is 5 to the 1/4. Because the bases are the same, what can we do with those exponents? We can subtract them. What is 1/2 minus 1/4? 1/4. So if we were doing this yesterday, we'd say, there, ta-da, our answer's done. But we started with radicals. We have to put our answer back in radical form. So 5 to the 1/4 is the same as the fourth root of 5. Almost wrote it wrong. Now, this is kind of hard for my brain to accept because look at your original problem. The square root of 5 divided by the fourth root of 5 is the fourth root of 5. That just seems weird. But if you convert it to rational exponent form, it does make sense. It's like a fourth of a factor of 5 canceled out a fourth of half of a factor of 5, leaving you with a fourth of a factor of 5 left. What? Yeah, okay, just ignore me. All right, number 13. I would not give you number 13 on a test. Number 13 is kind of a trick question, but I want you to see the process and see why I'm doing what I'm doing. So what I notice on the top is I have square roots on the top. On the bottom, I have fourth roots. If there would be a way to make those fourth roots turn into square roots, then I'd have square roots in the whole problem. Because these are both 15, I can change this to 15 to the 1/4 times 15 to the 1/4. The fourth root of 15 is the same as 15 raised to the 1/4. Those of you who like to cook and bake, what's a fourth of a cup and a fourth of a cup? Half of a cup. If you add a fourth and a fourth, you get a half. Well, 15 raised to the 1/2 is the same as the square root of 15. So now, this entire problem is square roots. Again, I would not give you this problem on a test, or if I did, I would either make it extra credit or I would give you some sort of a hint to help you figure out what your strategy is. But your strategy here is try to make the fourth roots match whatever root is on the top. And you can do that by adding those fractional exponents. Now that these are all square roots, we can put all of this under one radical. What is 6 times 10? And what's 60 divided by 15? 4. What is the square root of 4? Plus or minus 2. And that is a whole lot simpler than whatever we started with. So what if, in the process of simplifying radicals, those previous examples, they all worked out to numbers that were on our perfects chart? What if you get to the end and you have a number that isn't on your perfects chart? We still need to simplify it. So here's the process that we are going to follow. The third root of 54. Take a look in your thirds column. Do you see 54 in your thirds column? So here's what we're going to try to do. We are going to break up 54 into a number that is on the perfects chart times something else. So look at the numbers smaller than 54. Could you do 27 times something to get 54? 27 times 2 is 54. So all we're doing is taking 54 and splitting it into a perfect cube times something else. The reason we're doing this is, what is the cube root of 27? 3. So we have simplified it by pulling a perfect cube out from under the radical. Our answer is 3 times the cube root of 2. Be careful with your index. Make sure your index looks like an index in the checkmarky part and not an exponent. You want to make sure your 3 doesn't look like an exponent. Okay, so up here at the top, I'm going to kind of visualize what this strategy is. So you've got the nth root of a number not on the chart. We need to simplify the nth root of something that isn't on our perfect chart. We split it into the nth root of a number on the chart times the nth root of another number. And you can do this using division. 54 divided by the numbers in that thirds column until you find one that gives you a whole number. So let's try number 2. This time we're looking in the fourths column because it's a fourth root. The fourth root of 64 is not on the chart, so we want to split this into the fourth root of a number in the fourths column times something else. So look in your fourths column at numbers that are smaller than 64. 16, I really hope 16 works. Can we do 16 times something to get 64? 16 times 4. The fourth root of 16, according to our perfects chart, is positive or negative 2. So our simplified radical is plus or minus 2 times the fourth root of 4. Now, you don't technically need the plus minus here, because when somebody else does the fourth root of 4, they would put a plus minus on the answer. But whenever you're dealing with an even root, it's just a good idea to toss a plus minus in front of it. I would like you to try number 3 on your own. Go. So look in your thirds column at numbers smaller than 10,000. 1,000. 1,000 times 10 is 10,000. The cube root of 1,000 is 10. So our answer is 10 times the cube root of 10. Now, those of you who are maybe a little bit of lazy and don't like to show your work, at this step right here, if you don't put those radicals over the numbers, you are going to make a mistake. You're going to forget when you need to write the radical, when you don't need to write the radical. Don't be lazy on that step. Make sure you write the radicals on that step. The other thing we need to talk about with simplifying radicals is rationalizing the denominator. If you end up with something that has a radical on the bottom of a fraction, you can't leave your answer like that. It's bad. Radicals on the bottom are bad. So the third root of 2/3, if you end up with this as your answer, this is the third root of 2 over the third root of 3. We cannot have the third root of 3 on the bottom of a fraction. So I would like to turn 3 into a number that is on my perfects chart. So take a look in the thirds column. Is there a number in the thirds column that we could make 3 turn into? 27. So over here I'm going to write the third root of 27. I would really like my denominator to be the third root of 27. What do I have to multiply 3 by to get 27? 9. So we are going to multiply by the third root of 9. And if you multiply part of a fraction by the third root of 9, you have to multiply the other part by the third root of 9 as well. This third root of 9 over third root of 9 is basically a fancy version of 1. This thing equals 1. We are just multiplying by 1, but we're multiplying by a very fancy version of 1, so we end up with a denominator that we can actually evaluate. On the top, 2 times 9 is 18, so we have the third root of 18 on the top. So our final answer is the third root of 18 over, what is the third root of 27? 3. We no longer have a radical on the bottom, so we're good. So you have the fourth root of 8 on the bottom of this fraction. So you look in your fourths column to find a number that is on the chart. We see that 16 is on the chart, and if we multiplied by 2, we could make 8 turn into 16. If you multiply the bottom, you have to multiply the top. You end up with the fourth root of 14 on the top, and the fourth root of 16, which is 2, on the bottom. Try number 6 on your own. So in the denominator, we have the fifth root of 4. I look in my fifths column to think, what number do I want to turn 4 into? I want to turn 4 into 32. I think we can make that happen. 4 times 8 is 32. So I multiply the numerator and the denominator by the fifth root of 8. That gives us the fifth root of 24 over the fifth root of 32. The fifth root of 32 is 2. So we have the fifth root